So normally the main shaft, as I told you here, the bevel gear and the clutch and the base. So the clutch and base will be locked onto the main shaft. So basically I'll be having this. So, and as I told you here, so the M14 nut with the spring masher, I will screw this onto the main shaft, onto this part there, and this will secure the whole piece on the main shaft. So those thread are used to remove this whole piece with the tool. So basically what we will do is that basically the spring will go here. Spring will actually go there. And then the clutch base will be mounted onto this. So this is where the flower nut will be screwed on. So the spring will go here, and then I'll be having the friction plate which will go up there. So and then the flower nut will go here, and the flower nut will be screwed onto that part. You'll see the flower nut holds the system in place. So as I screw the flower nut, this will exert pressure on the friction plate, and the friction plate will exert force on the bevel gear. So as you can clearly see here, there is no force. So if my motor turns, so my friction plate will not turn. So as I continue to screw the flower nut, you'll see that when I will be turning the bevel gear, the friction plate will also turn, which will in turn turns my shaft. So a simple way to remember where the bevel gear will be, where the sprocket will be. So as I already told you here, the sprocket will be on the side where you have a hollow tube here, where you have a hole here. This is where the bucking bar and the ball bearing will enter. So the camshaft will be on this side. The sprocket will be on this side. So another way to remember this is that, so a way to know where the bevel gear will be. So where the bevel gear will be, this is the place where there will be a flower nut. So as you can clearly see here, you have the protruding threaded end on this side. So where we have the protruding threaded end on this particular side, so this is where the flower nut will be screwed on. So where the flower nut is, this is where the bevel gear will be. So we know where there is a hole, this is where the sprocket is. Where there is a protruding threaded part, this is where the bevel gear, which includes the clutch inner race, this is where they will be found. So that's it. So another small thing that we need to say is that, in fact, the problem is that the more I screw the flower nut onto that inner shaft, the more pressure will the friction plate exert on the bevel gear. But the thing is that if I screw the flower nut too much, the thing is that even when the cam turns and shift the inner shaft towards the left, it's like the friction plate and the bevel gear will not be completely disengaged. It's like there will be still force acting on the friction plate, so they will not disengage completely. So this is the problem that we can have. It's like when we screw the flower nut too much, the things that even when we press on the clutch lever, you'll see that there is they don't disengage. So in another way, if you actually don't screw the flower nut, if you actually don't screw the ephemeral in an appropriate way, the things that there will be never sufficient pressure that will be exerted on the friction plate that will cause it to press on the bevel gear. so they will never be completely engaged, like firmly stick together. So this is how you'll see that even you're not pressing the clutch, you'll see that the main shaft is not turning. So those are the two main problems. So I'm gonna repeat it again. So if you're gonna screw that too much, so even when you press the clutch lever, they will not disengage. They will not disengage. So what problem that we can have is, like, you might be riding your bike and your engine is on. So even when you press the lever, this does not disengage the motor. This does not disengage. So your engine will continue to turn the bevel wheel, which will continue to turn this friction plate as they're pressed together, which will continue to turn the main shaft, which will continue to turn your wheel. So it's like the clutch lever has no effect. So even the clutch lever is pressed on, you can actually accelerate your bicycle and it will go fast. So another example is that when they are not properly engaged, like this has not been screwed properly, you'll see that even when the lever is not pressed, and even you're actually accelerating like hardly, like you're accelerating. So if you're accelerating hardly, the engine is turning that very quick. So even you're accelerating hardly, you'll see that they are not properly engaged. So definitely they're not properly engaged. So the friction plate will not turn. This will not turn your shaft, which will not turn your wheel. So those are the two problems. So you need to find the right balance. We can test, like, you need to find the right balance so that when I actually press on the lever, it disengages it like good, like there is no like slipping and so on. So, and also when I actually release the clutch lever, there is a good like grip, like when I accelerate there, I know that there is a good grip, like the friction is completely stick together. There is no like slipping. So so that's it. So before like showing you the actual installation and removal, we'll be going quickly through the different parts of the clutch assembly. So this is the clutch wheel nut or the clutch flower nut, as we already said. So this is the clutch plate, the clutch friction plate. So as I told you here, then there will be a spring that will be pressing on the clutch friction plate. So when I pressed on the inner shaft, so this will lift up, then there will be a small spring that will be pressing onto the friction plate to lift it up. So number 3, I'll say that's the cover spring. That's the cover spring. So, and then I'll be having the assembly of the bevel gear and the clutch in the base. So that's the clutch. That's the bevel gear. So that's the bevel gear. That's the clutch in a base. And I'll be having the outer race and bearings. That's the inner race. So let's go through it. So number 6, that's the large seal loop or the outer race. So it will fit into that. So 7, you'll be having the main clutch spring. So those are the ball bearings. So those are the ball bearings. So this will fit into this, the ball bearings into this. So definitely. And then you'll be having number 9, number 8 are clutch pads. As you can clearly see here, those are clutch pads, friction material. So number 9, that's the clutch bevel gear. So that's the clutch bevel gear. And as told you here, so this will be fitted onto that. This will be fitted onto that. So all of those are the same, are one piece. So this will be fitted onto that. So I will be needing number 10, which is a lock nut accompanied with a spring gasket. So that's it. And number 12 is the peg, the clutch base peg. Number 13 is the clutch base. The clutch base or inner bearing race. Inner bearing race. And then I'll be having 15, which is the main bearing. So this bearing is fitted on the main shaft for support. As I told you here, there will be 2 bearings. There will be 15, which is here, this bearing, and 15, which is here. So this bearing will be fitted on the main shaft for support. And then 16, as I told you here, I actually, so all of those, this one, this one, this one, this one, this one, this one, all of those are the same piece. In fact, all of those are the same piece because the bearing goes over the main shaft. So that's the same piece. So that's the same piece. So adjustment nut, main clutch spring. That's the clutch pin manual. That's the flat key. That's the flat key. 19 of the flat key. Main clutch shaft. Main clutch shaft. 21. That's the pin. That's the pin. I'll tell him that's the pin. 22. That's the ferrule. That's the color. And as I told you, 22. 15, that's the main bearing. So as I told you here, we already know how this works. So this inner shaft goes into this, understand? And this collar goes over those two. When the inner shaft is into this collar goes over those two. And then this pin goes through all of those three. The spin goes through this collar, which goes through the main shaft, which goes through the inner pin. So that's it there. And then I'll be having that spring which will go and pressed on that collar, and then I'll be having this collar or adjustment screw that I will use to compress that spring. So this will as I will turn the screw, this will exert a force on the spring, and the spring will exert a force on that collar, and this will make it difficult, and this will shift the main shaft to the right. So that's it. And I already know that 23 that the tooth sprocket. So as I told you here similarly here, so this is fixed onto that main shaft. So I will need a nut, and spring gasket. Similarly here, as I told you similarly here, the sprocket is secured. So the sprocket is locked onto that main shaft with the help of a flat key. This is locked onto the main shaft with the help of a flat key. And to be able to secure the sprocket on the main shaft, I will be needing here the M14 nut plus the spring gasket. So, and then 24, this will be the ball bearing or clutch actuator bearing. And 25 is within the lever actuation. So those, we don't care about those. 25, that's the shaft fixed pin, so we don't care about this. So 26, I'll tell you this is the bucking bar. So I'll turn the camshaft, this will press on the ball bearing, which will press on the inner shaft, and so on and so forth. So those are the different parts. I'll be having the camshaft that will enter here. So those are the lever actuator and so on. So for example here, this is crutch screw base. I'll be having like heat shield spring and so on, clutch cable, this is clutch lever and so on. So those are the simple stuffs. But here it is. So that's all that we have. And that's a complete two-stroke engine kit diagram, the clutch diagram in fact. So that's it. So I'm gonna explain a small thing before we proceed to the removal and installation of the clutch assembly. So we need to bear in mind that this spring actually is exerting force on the inner shaft in this direction. So the spring is constantly like applying a force on the inner shaft in this direction. So when I actually like screw the flower nut onto the inner shaft, so as we have a spring here, and I will show it how it is in real. As we have a spring here, and as the friction plates like a little bit at a higher position than the thread. In fact, this is only a representation. The thread is is not that long here, it's a little bit shorter here. So as the friction plate is at a, I will say, at a higher position compared to the thread, so I'm not showing this here. So when I put my flower knot, this will definitely have tendency to apply force in this opposing force in this direction. And of course, if I screw the flower knot too much, or I continue to screw the flower knot, definitely there will be more force acting in this direction. Force on the inner shaft acting in this direction. So, for example, if I screw it again and again and again and again, so this might have the effect of compressing the spring here. So all of the system like work, that's a single system. They all work together. So that's only a small thing that I wanted to say, but the spring might not be compressed, so it all depends on the force of that spring. So when I'm actually putting the flower knot, it is eventually exerting a force, an opposing force in this direction, but this is not enough to compress the spring. So even when I screw it, the force might not be enough to compress that spring. So that's the small thing that I wanted to say. So I wanted to explain this. I will show you. So for example, if I will be placing the friction plate onto the bevel gear, so you can clearly see that the flower knot can easily reach the threaded part which is there. So when I will be that's a simple logic, and that's a way to understand it. It's a simple way to understand it. It might be not like this in detail. I will explain to you afterwards. So this is definitely simple. When you screw on the flower nut, this will definitely exert more pressure on the friction plate, which will exert more pressure on the friction material, which is found on the bevel gear. So that's one thing. The second thing that I wanted to show to you is that, for example, if I actually take that spring and place it in between the friction plate and the bevel gear, so this doesn't want to come off. So when I will be taking the spring and placing it here, and the friction plate will be, I'll be saying here. So the things that you'll notice that we'll have some problem for the flower to reach the threaded part on the inner shaft. So I will need to press on that to compress the to compress the spring. I will need to press on that to compress the spring so that the flower can reach the threaded part. So definitely you need to understand that. In fact, my spring, which is found here, exerts a force on the shaft, on the inner shaft, in this direction. And definitely this spring is exerting a force in this direction on the friction plate. And as the flower nut rests on the friction plate, this will exert a force on the flower nut, which is connected to the inner shaft. So this will exert a force on the inner shaft in this direction. So this is what I wanted to tell you. So we have two forces. I have my spring, which actually exert a force in this direction, and I have my for example, I have my spring. So that's a simple thing that I'm asserting. It is much more. It comes in a little bit more detail. So there is a force that the spring exerts in this direction on the inner shaft. So that's it. But definitely this is a balanced system, so there is no resultant force. The force that the spring exerts in this direction is not sufficient to compress the spring. But another thing I want to explain is that I will show you that the spring has a direct relationship in the force which acts on the friction plate, which acts on the friction material which is found in the bevel gear. So what I'm going to explain is that, so when this spring is already fitted between the friction plate and the friction material, and I've already screwed on the flower nut, and the spring is already like compressed completely. And the friction plate is actually rests on the friction material which is found on the bevel gear. So there is no space in between. You need to understand that there is no space in between. So it is already like firmly pressed on the I will not say firmly. It is already pressed on the friction material which is found on the bevel gear. There is no space in between. So when I will screw on the flower nut, it will not cause it like it will not cover like some empty spaces. There is no empty spaces between those two components. So the things that when I will screw on the flower nut, this will have the tendency to bring the inner shaft to the left position. This will have the tendency to bring it in this direction. So definitely when I screw on the flower nut, this will have the tendency to shift the shaft in the left position, and this will have the tendency to compress my spring. So the thing that actually occurs is that when you are screwing the flower nut, the inner shaft gets shifted towards this position, because this is obvious, because the friction plate is already seated, is already fits already perfectly on the friction material. So as you screw this will have the tendency to bring the inner shaft in this direction. This will definitely have the tendency to compress the spring, and this will definitely have the tendency to apply more pressure on the friction plate, which have the tendency to apply more pressure on the friction material which is found on the bevel gear. So that's the relationship with the spring and the flower nut. The spring has a direct relationship with the force which acts on the friction plate that actually acts on the friction material. So when the friction plate is already fits on the friction material, with this condition, when you screw the friction, when you screw the flower nut, this will definitely compress the spring. The more you compress the spring, the more the inner shaft is shifted towards the left, the more pressure exerts on the friction plate, which actually acts on the friction material. So then, for example, at this point, the system is balanced. There is no resultant force. So during the screwing motion, there is some resultant force because the spring is compressed and the shaft shift in this direction. But afterwards, that's just the balance point. So there is a force which acts in this direction, and that's it. So another problem that we can have is that if you screw the flower nut too much, this will have the tendency to shift the inner shaft into the left position too much, and even if we have the ball bearing plus the bucking bar, there might be not sufficient length for them to reach the camshaft. So we should find a proper balance in screwing the flower nut. So that's it. So all of the system, they all work together. The spring is completely related to the force which acts on the friction plate. So that was the thing I wanted to say. So we'll now proceed to the removal and installation of the clutch assembly on the bicycle. So I will be showing the removal and installation of the clutch assembly. In fact, it is already removed, but don't worry, I will show you the essential steps in removing and installing the clutch assembly. So you don't have to worry, I will show you the easy steps so that you don't make mistakes and so on. So first of all, I'll be completing the easy thing of screwing or unscrewing either the sprocket or the bevel gear. Either the sprocket, this is the bevel gear, or the sprocket. So I already explained how to actually remove either this bevel gear or this sprocket, but we will go through this very quickly, and after this I will show you the essential step when removing the clutch assembly so that you don't make any mistakes, so that it is very easy. And so that's it. So let's do it. So there will be no steps here, just simply a screwing and unscrewing thing. So as you already know, I will have the bevel, I will have the main shaft which goes in there, and as you can clearly see here, I have this bearing, I have two bearing support. You can clearly see the other bearing support which is inside, and as you can clearly see, I will be having another bearing here. So definitely this is the bevel gear. The bevel gear will be locked onto the main shaft by the use of a flat key. So this is the place where we put the flat key. This is the place where we put the flat key here. So that's it. So the bevel gear will be actually locked on the main shaft. So that's it. And then, so this goes, I'll say that this goes here. And then to secure this in place, I'll use a bolt and a washer. I will be screwing it here. So first of all, so I'm not doing the steps. I'm reminding you, I'm not doing the steps. I'm only showing you the screwing and unscrewing process. So that's all. So to be able to remove this, it is very simple. I will firstly need to remove that M14 nut and washer. So you take the M14 nut and washer, you remove it. So that's it here. And then, as I already said here, you'll be using the tool. You'll be screwing the tool over there. You'll be screwing the tool over here, and then you'll be screwing that ball. When you'll be screwing that ball, this will help you. This will go out. So then you'll be able to remove this out. So you will take this out. So this is simply a screwing and unscrewing process. I will do the same thing for this sprocket, and then we will do the essential step when doing this screwing and unscrewing process. So that's the other side of the bicycle. As you can clearly see here, you will be able to see the gear which is here. The support gear which is the support bearing, which is here. So definitely the main shaft goes in here. So for now I need to hit on the other side so that the main shaft goes completely in here, so you will not be able to see that the small race for the flat key. So don't worry about this, don't worry about that. So similarly, my sprocket will be here. My sprocket will be locked onto the main shaft by use of the flat key. Note that this thread on the main shaft, as you can clearly see here, so this thread here on the main shaft, note that this sprocket is not screwed on the main shaft. Remember that. The sprocket is locked on the main shaft by the use of a flat key. The flat key goes in here. So the sprocket goes onto the main shaft, slides onto the main shaft, and is locked on the main shaft by the use of a flat key. And then similarly, like on the other side, this thread is used to secure the sprocket by the use of a nut, an M14 nut and washer. So if you're gonna remove the sprocket first, you will firstly need to unscrew that M14 nut and washer. When you have already unscrewed that M14 nut and washer, then you need to do the same thing. You need to take that tool. And screw it on here. So it will be definitely like this here. So the sprocket will be here. You will take that tool and then you will screw that bolt. So this will help you to kind of remove this sprocket. So those are a simply screwing and unscrewing process, but we need to go through the steps when doing this to be able to do it without mistakes or for it to be not difficult. So let's go through this now.